that wide range apparently includes Susan. She said she wanted to enroll in the class. She may be the only one, because the first two people I talked to when I came there, I said, why in the world would anybody want to take a math class? That's right. Yeah. So maybe we just want to cancel the whole thing. I think we do have to be upfront and acknowledge the fact that there's a real discontinuity, a real kind of bipolar attitude about mathematics in American popular culture. It's not nearly so true, for example, in Hungary and other European countries, but in America that's terribly true. People are constantly, as Susan did, apologizing for their mathematical ineptitude and then talking about how their grandson is a great genius in mathematics. And so on the one hand, we always acknowledge that the tremendous advances of civilization have rested on advances in mathematics ever since the earliest times in ancient Greece, and then in the 17th century, and then this continues today and is explosive today, mathematical creativity, that is. But on the other hand, we have this feeling that mathematics is hard, it's difficult, it's occult even. Something's hidden there. It's kind of magical. Mathematicians pull out tricks. So there's a real uphill climb, I guess, for me to do, and I'm trying to encourage people to come along with me. You should have some interest in mathematics. If you have none at all, just don't show up. The title, Mathematics, Its Ideas in History. The history is very important. What I want to do really is talk about the nature of mathematical reasoning. That was the original title of the class. And I want to talk about mathematical concepts, for example, the nature of numbers, number systems, the nature of space, as we see it through geometry, and things like infinity, concepts where everybody talks about infinity, but mathematicians have really done something with the concept, and I think it's something that we can talk about in a fairly elementary way. Then I want to talk about mathematical proofs. The class is really about doing mathematics, but of course I can't talk about things like string theory. That's not my skill set. I can't talk about financial engineering because I don't know that much about it. And I'm not going to run this as a kind of a television Nova program. But I want to talk about actual mathematical reasoning as we see it in mathematical constructions, mathematical proofs, and see what makes the whole mathematical enterprise work, because it is fundamental to human thinking. I have a book. It's a great bargain. And if you want to look at it, it's $15, I think, was what I paid for it on Amazon. It's a classic book. It's not going to be the text for the class, but it is a reference for those who are interested. I think that's the most important thing that I can say. If you want to talk to me, I do have a list of books, references that you might want to look at. And in particular, there's also, I have the web address of a 43-minute Nova-type program that you can see, in which it discusses Andrew Weil's stellar accomplishment in proving Fermat's last theorem some years ago.
Great.
And so if you want a Nova presentation, do that. Mathematics is for me, though.
Great.
Thank
Thank
you.
you.